think running the robot for 30 minutes generates a terabyte of data.
What? Wow.
Yeah, so we would like at the end.
Hey everyone, I just had the honor to interview Tyler Han, who's a third-year PhD student at the University of Washington. If you haven't seen the original video, I recommend check out the Lychee AI YouTube channel. But this is the after-hour discussion where we just chat about robotics, his PhD journey, and how he started as a field testing engineer. We'll ask some tips for him for those who want to start robotics and maybe something for beginners. So if you want to hear more about his experience, stick around. So you started as aerospace engineering in undergrad, right?
Yeah, I had a pretty a lot of background. So I came in as the aerospace engineering.
Yeah.
I kind of thought I kind of thought that's what I wanted to do. I wanted to go into like space.
Uh-huh.
And then I think in my first year, my dad, who is like he does software, was like, you should probably get into computer science because that's where the money is.
Oh.
And so I was like, okay, I guess I can pick up a minor or something. Can't be, like I came from a high school with like some programming classes. So I had some programming experience and I thought it was kind of interesting. So then I started to pick up a computer science minor. And then as I got into it and I started learning about like AI, and then I think at some point I saw like a Boston Dynamics robot like start working, and I was like, wow, that's really cool. I'll just turn it into a major. So then I did a double major between yes. And then I think in my third year, as I was getting more and more into like machine learning and AI and kind of more of the state of the art, I realized there's a lot of math in all of this. And so I started taking some more math classes. And then eventually I picked up a math minor in addition to the two majors. And so I took a lot of classes in college, basically.
Yeah.
But I think it was a good intro. So like I kind of viewed my undergrad as a way to get the fundamentals right before starting on like these kind of later robotics problems. And I think that might have helped with like, reading papers and for example, the drifting task is kind of inherently rooted in dynamics and control and like a decent amount of math.
Yeah.
So the right background, I think, can be pretty helpful. Obviously, it's not necessary. Like, there's plenty of people who don't come from like taking a bajillion classes and do amazing as roboticists.
Yeah.
But if you have the capacity for it, I think taking classes at least early on while you're still motivated to take classes can be helpful.
Yeah, so you took up a lot more, or at least try to understand the math components for robotics. What about like the hardware aspects? Like, are you good with electrical stuff? Did you take up on that as well?
I have no electronics training.
Yeah, me too.
I think the other aspect I've always wanted to though, like I've soldered like, but I never really got into like like making PCBs or like doing like really getting dirty with like microcontrollers or something like this.
Yeah. What about the physical side? I guess kinematics, those you dealt pretty.
Yeah, I think I'm much stronger in physics than I am in other aspects. And in fact, I think honestly, I think CS is like my weakest side.
Really?
Like,
Even
I
if you
think
take up as a major or minor?
yeah, it's like I don't know.
Yeah.
Yeah, I think everyone has their own kind of perspective on certain problems in robotics, and I think my perspective is dominated by my physics background
Yeah.
or mechanics. I don't want to say physics because modern physics is kind of different, but
Right.
my mechanics background kind of dominates how I approach problems. And if you come from a learning background or like a kind of a higher level planning background, like some of my lab mates will like think about certain algorithms and things, and the state space that they have in their head, it'll be different. It'll be like things like manipulation, or be things like picking up an object and like drinking it
Yeah.
or drinking the cup, or and then setting it down somewhere else, like really high level plans.
Hmm.
People have different perspectives, and I think that forms what research problems they're interested in.
Yeah. And so after your graduation, what was kind of your journey? Did you go straight into PhD, or is like, yeah.
So I had an internship in high school, which it like it like scarred me
Oh
because
no.
it was really boring.
Okay.
I hope my boss is not watching this, but
We'll cut
it
this out.
was yeah, it was just like I think I was doing like front end web development or something, and I think I went in every day to the office, and I don't know, I was reading like APIs and web scraping and such, and
Yeah.
I don't know. I don't want to say these things are boring, like everyone has their own thing, but
Sure.
I just was not interested in doing this. I think eventually I figured out I wanted to work on something. I wanted to work on problems, or at least if I was going to do work, I wanted to work on something that was just unsolved. Like, if I look it up on the internet, I better like not see anything. Like basically those kind of things.
Yeah.
And so I think research was like a good direction for me to head in. I did some research in undergrad just to experiment with it, and I liked it a lot. I had really great mentors,
Hmm.
especially I think if they give you a lot of if they're hands off, or at least I like to work with like hands off advisors. Then you get a lot of room to breathe and kind of experiment and try different ideas, and then you potentially find a job just like doing this, which I think is pretty cool.
Yeah.
So I went straight into the graduate program because
Hmm.
I yeah was scarred by my internship program, and
Yeah, that's
I
fine.
wanted to work on unsolved problems.
Yeah, and it's more hands-on this way as well, I would assume. Can you tell me more about your first year? So you got into the field testing, and that is that because of the program, or is just something you wanted to experience as well?
I know this works different in different parts of the world, but
Hmm.
for the PhD program, it's not part of the PhD program. And like when I signed up to be a student with my advisor, he had some projects that I could jump in on. I
Hmm.
could also just like start my own thing if I wanted to, but um, he did he did basically like pitch this project as something that I could just start working on. And of course, coming into the program, I didn't know what I was doing, so I just jumped on the project. Um, so that's how I got started, but I kind of
Yeah.
viewed it as like I think I don't know how true this is, but I think people who come from industry have like a huge advantage in research in the sense that they have a really good understanding of what actual problems um, are, or like how certain things are used
Hmm.
in the day to day kind of on a day to day basis, or like how research is. So they have really good insight into what they might work on. Coming just straight out of undergrad and into a graduate program, I feel like I didn't have this insight, and
Hmm.
so I like that's another motive. That was like the main motivator, I think, working on this project, because it is more engineering focused. Like working with that full scale platform, there's some aspects of research, but it is, I'd say, mostly engineering.
Mm.
Um, but it was really good because it was like a state of the art vehicle. It had I don't know what other kind of vehicle had four GPUs and
Yeah.
a 64 core CPU on it.
Yeah, three
So it
lidars,
was
three lidars on it.
yeah, three lidars, four cameras.
Man.
I think running the robot for I think running the robot for 30 minutes generates a terabyte of data.
What? Wow.
Yeah, so we would like at the end of the day, we had to offload the data so that we can view it later.
Yeah.
So at the end of the day, we can't even go home. Like by the time the sun goes down, it's like 6 or 7.
Yeah.
You just want to go home because it's spent an entire day out in central Washington, by the way, which is like super dry. Yeah. Depending on what time of year, but it's like dry and deserty. And you just want to go home, but you have to sit there and wait for all the data to offload, which takes like hours.
Oh my gosh. You're using a USB
Uh,
port? Are they 3.0? Get it faster?
yeah, eventually they got like a dedicated machine to
Ah, dude.
parallelize like
Mm.
offloading, which made it a lot faster.
Yeah.
But yeah, before that, it was just it was miserable.
Oh man, that does sound like a pain. Yeah, just like
Yeah.
man. And so tell me, like, super curious. You had a slide with the car flipped uh onto the side. What happened there?
Uh, I don't think that was my fault. Uh,
Uh-huh, sure, sure. Uh-huh.
uh, if I remember correctly, I think we were testing. I think we were testing a new state estimation algorithm,
Okay.
and I think what happened was that I think someone had a different axis set to the vehicle. So instead of I think X facing forward, I think X was facing to the left or up or something.
Okay.
Um, and so it took like a really drastic sharp turn, which I don't think, I mean, like, if you, I don't know exactly, but, if you estimate your state incorrectly,
Yeah.
you might be thinking you're taking a turn when you're not really taking a turn. Um, but I think that's what happened. It, yeah, overturned, and, the vehicle's center of mass is like really high.
Hmm.
So if you take a really sharp turn, you'll just roll the vehicle.
Oh wow.
But it's happened actually a lot of times.
Yeah. Were there someone sitting in it while it made that turn, or were you guys just watch it fumble?
Yeah, someone was sitting in it.
Oh
Um,
no. Oh my
yeah,
gosh.
because in the beginning, they don't do this anymore. But in the beginning, um, this all of this got turned into a startup. By the way, so I don't work on this platform anymore.
Yeah, sure,
My
sure.
advisor is like has turned all of this stuff into like a startup.
That's awesome. Yeah.
Um, And so the platforms they use are slightly different now, and they don't have
Mm.
people in them. But this was back when they do have people in them. So someone had to sit in the vehicle and like e-stop it if it looked like it was about to do something dangerous.
Yeah.
Um, but yeah, so occasionally we would roll the vehicle, and we'd have to go and apologize to the driver for rolling the vehicle, or like it wasn't directly us, but the algorithm
Yeah.
that we created rolled the vehicle.
Wow. So if this were to have, I assume you guys didn't test it in sim. You tested direct.
Uh, Actually, yeah, I don't think we did sim testing
Yeah. So
for that
if
platform.
there had been something like the Will Lab, or at least the simulation you could test, you guys would probably saw that coming earlier, right?
Yeah, I think we did have ways to verify it. For whatever reason, I don't think we caught it in time or
Mm,
something. Like
yeah.
these things happen, and then something gets put in place like retroactively.
Mm,
So I think something did go in. Like we did have like a new testing pipeline put in place after that incident. Um, but as for like simulation, I think that's a great question. For like off-road navigation, it's a bit hard because um, at least the application for it is like driving in completely like in the wilderness and completely unknown regions.
mm,
So you could provide a simulation environment, and there are that tries to model like like a forest region or something, but there's only so much diversity you can capture in a single simulation environment. Um, I don't know. If you just think about video games, someone has to go in and design all these things. But the application is like the wilderness. It's like completely unknown regions. It's like you'll almost always find things or see and be in a scenario that you've never seen before.
yeah.
So that can be really challenging to like even though you do work well in simulation, does it really work in the real world? Because I've never seen this scenario before.
Mm,
Um, so
huh.
yeah, it can be hard.
Yeah, that's a good point. So there are some scenarios that could be out of the sky, out of the world. And you mentioned about, I think there's like a hot topic with domain randomization. And so can you explain a little bit on that? And so domain randomization, you want to touch on scenarios that's like basically all possibilities? Mhm.
Yeah. So the theory for domain randomization is that um, if you so like okay so let's take away domain randomization, and let's just say I in simulation I have a certain mass and a certain friction that I'm setting the robot to,
Mhm.
um, and I train it on that. So in theory the policy has been trained over a certain mass and a certain friction. So if the mass and friction in real life did match that, then it should perform in theory exactly as expected.
Mhm.
Obviously that's not true. So the real mass, like real friction, say you don't know what it is.
Yeah.
So in simulation, domain randomization is supposed to be like a range of potential values. So let's say I randomize from 2 to 4 kilograms
Yeah.
and from like 0.2 to 0.4 coefficient of friction.
Mhm.
If if I train over this environment, the policy should find kind of should converge to something that works in all of these scenarios.
Yeah.
The reality is though it gets worse. Like the reality though, because it can't do the best it can, because there's so many different scenarios, it just
Mm.
finds the best for all of them, which is also like the worst of each one.
Yeah. I
And so
see.
you transfer that into the real world, and if say your real world setting was like 3 kilograms, or was between 2 and 4, and between 0.2 and 0.4 for the friction, then in theory it should transfer. Um, at least that's the theory. I can't stress that enough that it almost never works.
Mhm. Yeah. Is that so? I think I understand a little bit. When you're talking about the strain gauge, right? Because you want to model the friction or the coefficients of the car, and so by having that number, you can then kind of give it a range to randomize within. Is that correct?
Yeah, so I think before this ring gauge, I was randomizing. I don't know. I just gave it some random number. I think I put it to like 0.5 to 0.7.
Right.
Um, and so the friction in simulation was a lot higher
Uh,
world.
uh,
When I did have the spring gauge, I had 0.4, but it's a high school spring gauge, and the way I measured it was not really like I literally just attached it to the vehicle and then dragged it on the floor. It's not a lab setting, so um, I had like maybe one significant figure, and so who knows how much variance on it. So
right.
I added some like point, so I just added a little bit of width to it, so 0.3 to 0.5.
Uh, okay. So I remember, I guess from a visual perspective, your domain randomization has like a circle of probability, and there's also a physical world of possible
Yeah,
scenarios.
yeah.
And so by you having measured that coefficient, you kind of like shifted that probability closer to the real world. Is that how we can kind of visualize it?
Yeah, I think that's exactly correct. So the sim to real gap
Yeah.
is like some people's perspectives on it is that it's just the dynamics. If you think that the gap is just the dynamics, you can think about like, if you're familiar with like the MDP and like the RL formulation,
Mhm.
the MDP is basically just like the dynamics of your problem.
Yeah.
You have some MDP in the real world, and then you have some MDP in simulation. And the policy is, of course, solving the one in simulation.
Hmm.
But if these two things are really close, then the policy will also solve the MVP in the real world. It's just
Yeah.
that these things are, like you said, are not really like you can bring them closer together, but they're usually not that close.
Right. Wow. That's fascinating. And I think there's always kind of the, at least for me, is you have the kind of traditional control policy, and then you have the reinforcement learning policy. Do you think that the traditional one are slowly like fading away? I know PIDs and all that are still commonly used in like edge devices or like low computing, but it seems like everyone's just shifting, throwing the problem to reinforcement learning now.
Yeah, I think as far as industry goes, MPC and model predictive control is still like the industry standard.
Mhm.
Just because and so actually a lot of my research is focusing on how to bridge this gap.
Ah,
Like most of the research, like you say, is more towards learning. Um, and the advantages for learning is that it's like kind of scalable. It's in you we are kind of in a world of data, so in theory you can like kind of program behaviors through data.
mhm.
But for real world problems where you need to ensure the safety and like reliability of certain things, you need to ensure that it's profitable, that it's like maintainable, all of these different requirements. It's much easier to design a clear box system and use that than the black box system and just hope that it works.
Yeah.
Um, so for that reason, I think the industry standard is still like control algorithms. Um, but I'd say in research, people are trying to find ways to merge these two things. At least like my research is mainly about this.
Mhm.
Um, is kind of merging, and my advisors too in my labs. It's like about how to merge kind of these traditional algorithms that are reliable, interpretable, um, and can provide some safety guarantees, stuff like this, and how to merge them with like the nice behaviors of using data. Um, that's like I think that's the goal. I think the future will be some combination of these two.
Mhm.
Um, I there's like there's more recent developments on like using large models, like large language models.
Yeah.
Um, I may have a hot take on these, but I don't think that's the final goal for robotics. Like I can't imagine like eventually maybe 50 years into the future or something, it will just be a single neural net or something that has been really validated and really proven to work.
Yeah.
But until then, I am not trusting a 1 billion parameter model
Yeah.
on a robot that could potentially like swing its arm and just knock me out. Like, there's
Absolutely.
no way I'm putting that on a robot. Um,
Yeah.
yeah,
Wow. And I think NVIDIA was talking about these foundational model, like we're waiting for that moment to happen. And I guess that sets like a baseline for, I guess, different models for that. So maybe by then we can have a little bit confidence, like, yeah, let's try to use it, perhaps. I don't know. Um,
yeah. No, I think it's a great goal, and yeah, like far into the future, I think there should be something that I don't know, just like from a philosophical perspective, there is like
mhm.
whether or not you believe there's a fundamental like truth to the world, is like kind of gives you insight into whether or not maybe you personally would think a foundational model is the correct way. But as far as robotics goes, like the physical world is like a foundational truth,
Mhm.
um, at least for robots.
Yeah.
And so, um, at least from my perspective, I think it kind of makes sense from that perspective. Computer vision and language, for instance, has a different take on research. And
Mm.
of course, that's for a good reason. Like, they have data sets and benchmarks that do work, that do kind of transfer well to, or some amount transfers to the real world and real world tasks.
Yeah.
But for robotics has for like in the entire history of robotics has struggled with coming up with um, consistent benchmarks that are representative of real world problems.
Mm.
But benchmarks are really important for research and science because if you have some method and you think it works as you think it's an improvement on other existing methods
Yeah.
and you want to show that somehow, a benchmark is a really easy way to show that.
Hmm.
But the issue is that robotics kind of is entangled with like engineering in the sense that there's so many different metrics that people of different backgrounds care about.
Yeah.
Um, but with more people from language and computer vision and like all these like kind of more metric focused fields coming in, they're kind
Hmm.
of pulling away from engineering, at least
Ah.
for research, in the sense that these benchmarks are becoming more focused for better for worse.
Yeah.
And so, like from my perspective, at least from an engineering background, they're seeming to like they seem to leave behind um, the fact that like people may care about different things,
Mm.
and so there's a little bit of attention that's being kind of dragged away from full stack robotics and like full scale development and like kind of
Yeah.
doing everything from like scratch and hardware and getting dirty basically,
Yeah.
to like more evaluation.
Uh-huh.
um, and I think that is the eventual goal, like is to have like really good benchmarks, but I don't think we're quite there yet. Um, but the field
Mm.
is moving that way. And so my hidden agenda with like kind of Wheeled Lab and stuff like this is to invite more people into like I don't know, do the entire stack basically.
Mm.
It's like get dirty with the
Oh,
entire
yeah, I like that. And because I've gotten questions from people. It's like, hey, I just only want to do reinforcement learning and robotics. Like, I don't want to touch on the robotics part. Like, I just want to see a humanoid start standing and doing tasks. But it's like, man, you're missing out on a lot more stuff than just
Yeah.
coding and reinforcement learning. Yeah, okay. I want to shift a little bit. So the three things we talked about in your real lab, the agility control, the elevation, and then what was the last one? Was it the visual
Yeah.
aspect? What was like the on among the threes, what's the most challenging one for you?
So I think the way I managed the project, I really only had like I was mainly responsible for the drifting policy, which is why I was
Hmm.
able to talk more.
I see. Yeah.
Um, and then I had like trusted collaborators work on different on the other tasks.
Hmm. Hmm.
Um, but not to toot my own horn, but I thought drifting was the most difficult one.
Yeah,
Um,
sure.
and I don't know how true that actually is. Like maybe the other policies, like, I do have like really amazing collaborators, so they could have also just like been really
Mm,
good.
yeah.
Um, I think it's just that the drifting task is like super unstable from like a control perspective. That's really hard.
Hmm.
And I did have to like, I guess in terms of work, I had to do a lot to actually get it working. I had to change the simulation models. I had to actually change the parameters. I had to do a lot of domain randomization. I had to put
Yeah.
the robot around. I had to add all of these settings and engineering tricks to get it to work.
Hmm.
Um, I think the elevation and visual policies, at least when I look at the environment configurations, especially also the simulation models, they aren't as kind of, uh, they don't have as high kind of requirements for like the accuracy of the simulation and kind
Hmm.
of the amount of sim to real tricks. I guess the visual policy did have a decent amount of sim to real tricks,
Yeah.
um, especially working with cameras. The elevation policy, I think, was a lot of reward shaping, and but the elevation map transferred decently well.
Hmm.
It is a kind of an abstraction that is free from sim to real cap, or not
Yeah.
completely free, obviously, but like it's not as big
Hmm.
of a gap.
Yeah. Yeah, and I don't know much about reinforcement learning, but the fact that you mentioned you have to introduce some instability in order for the car to start learning that there's a way to drift. I think that was kind of new to me, and it's like, and I think you said it was more of a constantly adjusting and instability. Is that correct?
On like controlled instability.
Yeah, yeah. So is the
Yeah,
car
yeah.
technically in like kind of a unstable state most of the time?
Not most of the time, just when it
Okay.
needs to drift.
Ah,
So like while the wheels have traction with it, or just like imagine while you're driving, like
right.
you are in control of the vehicle most of the time. But if you are like driving over ice or something, you'll
Yeah.
start to feel like you lose control.
Yep.
But if you're a professional driver and you wanted to drift the vehicle, um, you do purposely have to slip out the vehicle to get it to drift.
Ah,
And so
uh-huh.
during that period, you lose a lot of control authority on the car, but it was intentional,
Yes.
or at least it should be intentional.
Yeah.
And so if you did it correctly, it should like, you should be able to drift through the turn, even though you're losing control authority, but then, quickly regain it if you need to.
Right.
And so that's what kind of controlled instability is. But for animals, I think like I really like this concept because for
Hmm.
animals, this is really intuitive. Like we don't even have to think about this. Like we're
Yeah.
unstable, at least when we're walking on like when we alternate legs, for instance.
Uh-huh.
There are periods, or even when we're running, there are periods of times where like we don't even have any feet on the like we're not in contact with the ground at all or something.
True. True.
Um, but it just comes so naturally to
Yeah.
like us as animals that like we're unstable half the time, but we don't think twice about it because it's like natural.
Right.
But for robots, it's a really hard concept because
Uh-huh.
you want to be constantly robust to your environment. Um, but I think as we get better at robot learning, we'll start to kind of realize that's not the requirement. The requirement is like maybe you can be unstable, but you have to do it in a kind of a controlled and athletic way.
Yeah.
Um,
Wow. Yeah, because I mean, at least the leopards, the tigers, they have tails to kind of compensate that. Us humans, that's interesting. Like I know when you're standing and you close your eyes, you're constantly shifting weight. So I think that's what you meant. Like controlling it. And okay, and I guess one interesting question I have is like your day-to-day work as a PhD student. You said it's are you second year, I think?
I'm a third
Third year?
year.
Yeah. So what's it like for a third year PhD student, like a day-to-day or a month-to-month like
Yeah. Um, so third year, so I'm in a 5-year program. I know it can be different for people in different parts of the world.
right?
But I'm expected to graduate in 5 years, which means that I'm kind of in this transition between I don't know if this was like everyone else's college experience, but you know, if you go into college and you're like exploring your first couple of years, you don't set a lot of expectations for yourself because you're just
Right.
exploring, figuring things out. That was what like the early part of the PhD was like, and then now I'm trying to start focusing. Like I can't just like yeah, I can't just make robots drift anymore. I have to like come up with some kind of agenda and thesis
Mm,
for what I've been working on for the last 5 years.
yeah.
And so for me, it's like trying to figure out what my research is all about.
Hmm.
Um, so actually, Real Lab was really nice for me because I think for a time I was like really half and half on either continuing academia or going into industry.
Hmm.
But you know, I have heard that you should go into academia if you like mentoring, if you like teaching. And I feel like I knew that about myself, but I think Real Lab kind of reinvigorated that in me.
Yeah.
Because you know, I don't know. In my first year, I had spent all this time working on this like platform that was completely inaccessible to people, and so
Mm,
maybe I kind of lost touch with it. But after kind of getting back into like communicating about how, well, literally anyone could do something like this, it was nice for me to get reacquainted with like uh, I guess like more like teaching and mentoring and this kind of thing.
yeah.
Um, but then, so now as far as like my research goes, I am working on like I'd like to make like my work about imitation learning. I You might already be able to tell, but I do want robots to kind of behave um, kind of athletically and kind of similar to humans.
Mm,
Um, And I think the way to do that, at least scalably, is through kind of imitation learning, which basically means, you know, you provide some expert data, so like coming from like a human
yeah.
or some animal or something, and then you try to get the robot to match that or imitate that data. So whether it's like running, jumping, uh, kind of picking up an object or doing something else, the robot should kind of look and
Mm.
behave like a human.
Oh, interesting. Yeah, we see a lot of humanoids kind of being developed, adopted as well. Some can do backflip. I can't even do it. So like you can't imitate me. Don't imitate. Don't learn from me. That's cool. Would robots be learning from animals as well? Like, you think that's possible?
Uh, like quadruped animals.
Yeah, right.
Uh, I guess it's possible. There is like there's this concept of cross-embodiment in robotics where
Okay.
you know you might have data come from like a quadruped or like a dog, for example, and
Yeah.
you might want to apply that to some other thing, like a let's say like Spot is a you know, Spot has that robot arm on it. You
Hmm.
know, maybe it is like kind of picking some object
Yeah.
and then walking over and dropping it off somewhere else. Um, Maybe you want to do the same thing as a human.
Hmm.
Um, or actually, this is probably more fitting the other way around. Maybe the human is demonstrating some data where it picks up a cup and puts it on some other table.
Uh,
And you want to imitate that behavior on Spot, but obviously Spot doesn't have 2 legs and 2 arms. It has 4 legs and 1 arm.
yeah.
And so you have this concept of like cross embodiment where you have like data from one embodiment and then you want to perform it on some other
Hmm.
embodiment.
Oh, I've seen a dog hold a cup before. on YouTube. Just like
Really?
two hands, just like, hey, give me your hand.
Oh,
Just like a kind of a begging pose, but like you just pick
I
cups.
mean that's actually pretty interesting because we do manipulate things with like opposable thumbs. So if your embodiment doesn't have
Yeah.
thumbs,
Uh-huh.
um, yeah,
Oh,
interesting.
that's amazing. So would it be more with the imitation learning, would that be more humanoids, robot, or is there like specific robots you're looking at?
So right now I'm in the process of like writing a paper. It'll be due at the end of the month, so I'll
Hmm.
release it then.
Yeah.
But right now I'm mostly in methods, so I'm kind of developing the theory and like the math and like the code and stuff like this.
Hmm.
And then I think after that is released and I've done like my due diligence about like kind of proving connections,
Yeah.
some other qualities about this.
Mhm.
I'll try and ship it on well mainly the robots that we have in the lab. So like we have like manipulators, we have a spot robot, and then probably some of the cars as well for like navigation tasks. Um, yeah, so I don't know. I'm kind of interested in like general algorithms. So I think in theory it should work on all of
Hmm.
these things.
Yeah.
We'll
Yeah.
see.
Would that be, I guess that would be shifting a little bit more away from Will Lab, or right? Is it Will Lab's dedicated for wheels?
Well, at least in terms of imitation learning,
Uh,
like I think you can still try to do imitation learning on Reels.
yeah.
Like if you want to, like, I mean, let's take like the full scale platform, for instance. Like it's much easier to demonstrate uh how to navigate through environment by just recording
Hmm.
data of like some human driver, avoiding trees, maybe crashing through some bushes,
Yeah.
and then I don't know, avoiding ditches, not rolling over, stuff like this.
Uh,
It's way easier to program through demonstration than it is to program through like tuning.
yeah.
So it's still possible on wheels.
Hmm.
Um, but in terms of like, yeah, my like for my work for my thesis, um, I think it has to be. It can't all be real lab. I think real lab will be a big component, but uh, yeah, I have to kind of go towards uh, what makes up like the bulk of my
Yeah.
5 year.
Oh yeah. Well, that'd be a challenge for you, but I'm pretty excited for your journey on this. Especially yeah, something that
Yeah,
for what do you say, like impacting something that's more impactful uh with your project or dissertation. Is that what they call it? Yeah.
well, I don't think. I mean, I think. So I don't mean to say that like Wheel Lab is not impactful. In fact, I think
Yeah.
I've talked about like a Wheel Lab too, maybe. Um, I just can't make my like thesis about it because I do have to produce something that is like, uh, I'm an expert in the field on this particular subject.
Mm-hmm.
Um, and while it is a goal of mine to like produce uh kind of accessible work,
Yeah.
um, I don't think I can make that my thesis.
Absolutely, yeah, and I appreciate
Uh,
on top of that because like for you guys who are pretty much the expert, you have to constantly juggle for your own knowledge to deepen that knowledge, but you're also trying to bridge that gap for other people who are joining in this journey, and so that's something I really appreciate. For if you were to motivate a I guess beginner roboticist who wants to embark in this journey, or even doing a PhD in the future, what's something that you would advise absolutely don't do this or absolutely do this or something like that?
oh, great question. Um, I think maybe I'll address the PhD part first. If
Sure.
you want to do a PhD, I think, or if you're on the fence about it, I think at least for me, like the main decision point was whether or not I wanted to work on unsolved problems. Um, if you find a lot of like, uh, if you're really excited about working on something that is unsolved, that you can't just like walk over to your coworker and say like, "How do I do this thing?" I think research is definitely for you. Um, you do have to find like it can be also like a pretty big function of your environment. So you do want to make sure that you find a very encouraging environment for you to kind of fumble around because, research, you will fumble around, and kind of grow as a researcher. But yeah, basically, if you want to work on unsolved problems, I think research is definitely the space for it.
Mhm.
What would I say to motivate a beginning
Yeah,
roboticist?
for beginner, think about how you started, I guess, where you stumbled a little bit and realized, oh, I guess I think for future people, they probably should do this instead.
I think maybe this maybe goes back to a little bit what I was saying before, like interdisciplinariness
Okay.
of
Yeah.
robotics. I was most like, why did I go into robotics as opposed to maybe like computer vision or language or like maybe other aspects of like, really promising AI fields.
Hmm.
In my opinion, robotics is the hardest problem.
Yeah.
It's so, I feel like the solutions are just like the solutions to the problems that I encounter are never, it's like it, maybe this sounds bad, but it almost feels like I'm never enough, in a good way,
Yeah.
in the
Yeah.
sense that like the knowledge I currently have is almost never enough to solve the problem
Mhm.
that I'm engaging with, which means that I'm constantly challenging my assumptions about how certain things work the way they do and my understanding about the way they work, um, that just constantly invites me towards like other directions and new areas to learn about.
Mhm.
And I think robotics kind of encourages that. And um, I think if like, if you're someone who loves learning about new things and like loves to be wrong about things, I think robotics is like definitely the field. Like you will always be wrong, basically.
Yeah. Oh, that's amazing. I think I can resonate with that because I'm constantly thinking about if I'm doing this right or wrong, but you just kind of have to keep going,
Yeah,
experiment,
yeah,
and
yeah.
keep
It,
trying.
it also like yeah, I think that's a great point. I think like you're saying, it takes a good amount of foolishness because you're doing it wrong, but you still got to do it anyway. So yeah, I think that definitely plays a role.
Yeah, that's amazing. I think that's a great advice for robotics. And it can get overwhelmed, but you just gotta keep going. Be a little bit stubborn, I guess. Even
Yeah,
though you're not
definitely.
might not be right. Yeah. Okay. Well, I think that's pretty much it for time. We're good on that. Is there anything last thing you want to mention or something that you've always wanted to tell the world? At least to my small audience, this very small audience of roboticist students.
Uh, yeah, I guess I don't know if I have to tell your audience, but work on robots. Like,
Yeah.
you want to do robotics, get dirty with the hardware, and um, you know, don't as you're training models maybe, or if you do find the time to get into wheeled lab, um, just remember that what you see on the screen isn't everything.
Mm,
Once you start deploying in the real world, it actually may work, even though it doesn't work on the screen. Or most likely it will just not work, even though it works on the screen.
yeah.
Um, but yeah, uh, yeah, robotics is exciting, and you gotta make sure that it actually deploys on the real hardware.
Mhm. Awesome, awesome. All right, Tyler. Well, thank you so much with your valuable experience. So that's the end of our discussion. I really learned a lot from his perspective about the robotics field. If you have some questions, feel free to leave a comment below. And if you like these interview type of questions, feel free to leave a thumbs up. And as always, thanks for watching. Check out my other videos, and I'll see you next time.